Bioenergetic? I know what you are thinking now. You may think that I have never studied metabolism yet. I did not do that well in biology or in chemistry in high school. I think that only nerds like or study biochemistry. Or do I really need to know bioenergetics to study exercise physiology or to exercise to improve my fitness? To study energy metabolism or to just exercise properly, you need to first understand the rule and concept of bioenergetics. Do not worry, I will not make this difficult or I will not require you to master chemical calculation formula. Nevertheless, there are some important concepts that you must invest effort into understanding. But once you do this, you'll improve your understanding of the design of energy catabolism and thereby make a future study of the metabolic pathway a much easier process. Another benefit of an early study of bioenergetic is that you are introduced to the concept of free energy. And you can also improve your comprehension of the function of enzyme, like the coupling of chemical reaction and the ability of a select number of reactions to change direction in response to changing cellular metabolic condition. For example, here the student think creatine is one of the best supplements for improving power or high-intense exercise performance. This student should answer why or how creatine supplementation work. But step 2 here is just then a miracle occur. We, as a kinesiology student, cannot say like this. First of all, the larger field of the study of the science of energy transfer is called thermodynamics. While thermodynamics theoretically covers all aspects of energy transfer, most applications of thermodynamics pertain to energy transfer between heat and mechanical work. Therefore, thermodynamics has a main application to machinery. Another branch of thermodynamics is energetic, which concerns energy transfer in physical or chemical conditions. Bioenergetic is yet another branch of thermodynamics and concerns the study of energy transfer in living organisms. Bioenergetics is the study of energy transfer within the living organism. And how about what is your energy transfer? Class, think of a muscle having stored energy in the form of micromolecules such as fat, glycogen, phosphorylate, glucose, protein, or amino acid. The food you ingested in part is to maintain a supply of this molecule. Energy is stored in this molecule between the atoms. How is this chemical energy released and transferred within the cell to do further functions such as muscle contraction, molecule transport, conducting action potential, and so on? Simply, how is chemical energy transferred to the mechanical energy of muscle contraction, molecular transport, or the action potential? What determines how much chemical energy exists or is released during a chemical reaction? What determines which way a chemical reaction proceeds and therefore which molecule are the substrate and which are the product? So studying bioenergetics gives you the answer. And why do we need to study bioenergetics? Because the understanding of metabolism provides the direction to better understand how skeletal muscle generate energy and how and why the body responds to exercise the way it does. The study of metabolism is aided by studying bioenergetics. These are examples of energy transfer within the human body. This slide presents the lactate dehydrogenase reaction. You will learn soon this reaction in detail, so do not worry about it too much at this time. This reaction is illustrated to show pyruvate, NADH, and a proton being converted to lactate and NAD+. However, in some tissue, such as the heart myocardium, this reaction mainly occurs in the reverse direction. In addition, inactive muscle also can have this reaction go in the reverse direction. Why is this? This is like any reaction is potentially reversible. I believe that you think of what determines which way the reaction proceeds. You will know soon and why this is and why determine and which way. This slide presents the creatine kinase reaction. You will also learn soon this reaction in detail, so do not worry about it too much at this time. This reaction is essential for the muscle to support a rapid ATP regeneration during the onset of exercise or for sustained intense muscle contraction. However, when we are at rest, there is no creatine phosphate breakdown and ATP production. Why? When we stop exercise, there is a rapid reversal of this reaction so that the muscle creatine phosphate store is rapidly regenerated. Why are some reactions so responsive to cellular condition for their occurrence and or directionality? You are going to learn this soon also. Do not worry about it. When comparing the lactate dehydrogenase and the creatine kinase reaction, why is it that only the latter involve ATP regeneration in the direction presented? You are going to learn it soon too. I hope this example and question reveal that there is a lot to learn about metabolism besides memorizing reactions, substrate, and product. Understanding metabolism, rather than memorizing it, require learning bioenergetics. Bioenergetics is summarized by the two laws of thermodynamics, which we'll call the law of bioenergetics here to study exercise physiology. Remember that thermodynamics is the study of energy transfer, and as bioenergetics is the same study but restricted to living organisms. Bioenergetics is a component of the field of thermodynamics. The first law is energy conservation. When discussing energy, the command was already given to how energy is conserved. By conserve, it is meant that there is no loss of energy in any energy transfer. During energy transfer, the total energy remains unchanged, with only the quantity of individual component of total energy changing. Energy cannot be created or destroyed, but can change from one form to another. This is the first law, energy conservation. The first law is important, but it has limited practicality when you learn exercise physiology. For example, why do some chemical reactions proceed one way during specific conditions and then go in the other direction when other cellular conditions prevail? Why can muscle use chemical energy to perform mechanical work, but not use mechanical work to regenerate chemical energy? In short, what force controls the direction of energy transfer? This is answered by the second law. The second law, directionality of energy transfer. Understanding the force that governs the directionality of a chemical reaction is an essential prerequisite to the study of metabolism. As such, this lecture is vital to your educational preparation for the section of muscle contraction and metabolism that follow. Energy transfer always proceeds in the direction of increased entropy and the release of free energy. Class, I would like to simplify the second law, so focus on release of free energy. So, energy transfer will always proceed in the direction of the release of free energy. And free energy represents a form of energy that the cell can use to perform work. And metabolism is only able to harness around 30% of free energy release in chemical reaction, with the remaining 70% given up as heat. I would stress the importance of understanding gives free energy or just free energy. Based on this energy form, we can name chemical reaction according to the change in free energy. Reaction that have a negative free energy, we can call delta Z, but how about I just want to simplify. So negative free energy are termed exergonic reaction. This reaction will occur spontaneously to form the product. When the free energy is zero, there is no energy transfer, or in this example, no chemical reaction takes place. As such, the concentration of substrate and product do not change. In this situation, these reactions are termed equilibrium reaction. Now, you may have heard of another term, that of endogonic reaction. Theoretically, endogonic reaction have a positive free energy. I use the word theoretically for an excellent reason. There is no such thing as an endogonic reaction. They do not exist. By definition, such a reaction would have a positive free energy, which can be interpreted to mean they need energy input to proceed. The problem is that once a reaction proceeds, based on second law of thermodynamics, it has to be an exergonic reaction. This is why I express endogonic reaction to be a theoretical construct. I'm going to explain this chemical reaction in detail and very practically and very easily when I lecture the creatine kinase reaction concerning the couple of chemical reaction. The coupling is the ability of an enzyme to combine more than one reaction, typically exergonic and endogonic reaction, to produce an overall exergonic reaction. Thank you.